doing simple harmonic emotion. Trying not to cry. We'll see how it... Is this... It looks good. He's gonna be a mass made easy. I'm just gonna look for all the questions that have things bobbing and weaving. That will give me exactly what I'm looking for. Good afternoon. Good afternoon. Stream, chat, and YouTube. We're just gonna go through all the papers probably until I cry. Wait. Angular frequency. If we look at the data sheet on the circular motion part, we see that it's looking for the angular frequency as seen by my mouse. So we'll look at that. It shows the frequency. What does it give me? It gives me speed and amplitude. That seems to be a problem. Angular maximum speed. I don't know. I get distracted so easily. People are the worst. So that is mod 19.4. I don't. That has frequency in it. I guess it has to be that. So it has to be the angular frequency equals 2 pi f. I should probably get the data sheet up. I can do that. OCR A-level physics data sheet. So I don't need that. Where is it? There you go. And if I open that in a new... No, I'll just go to it, but... I'm only gonna need these two. That's all I'm gonna need. So, I'm looking at this one right here, but it gives me the speed. I don't know if do I have the radius? It gives me the amplitude, but I just don't know. Shut the fuck. We're gonna look. We're gonna have to get a angular speed value because it gives me a maximum speed and not an angular velocity value. So if we look at the data sheet, it gives us a v equals angular speed r. So I'm gonna write that down. R. If it's harmonic oscillator, if that means it does that, surely the amplitude would be half of that. So it would be 2.5 or 0.3. That is 5, 6, 7, 8. So that is 2.8. So 24 equals angular speed. I need a pen tool so I could just draw, but I don't know how to do that. So you're just gonna have to listen to me speak. But now with my training as Bed Wars Pro, I can do that. And then if we do 24 divided by 2.8 gives the angular frequency, which using my own calculator gives me a value of 8 point... Oh, fuck's sake. Oh, that's not what I'm looking for anyway. That's gonna be the angular speed. 8.6. I'm gonna round it up. No, I'm gonna do 5.7. 8.57, which is what I got on the calculator. Then with this, I'm gonna go for the equation I was going to use. So W equals 2 pi frequency. Looking for the frequency, but I don't care. So it's gonna be 2.8 equals 2 pi f. Then 2a divided by 2 pi equals f. And we're going to do that calculation. I don't even know if this is right, but... Oh, fuck you. That seems like... That's half of that. Okay, just completely ignore what I said, you fucking bastard. So I have absolutely no idea how to do this. I might get YouTube. Feynman's technique. Zendaya. Why is Zendaya in my kitchen nightmares? Modeling. A-level physics paper.
Okay, this is OCR.
How the
lots of words. Zero. Okay. Angular frequency. The equation is V is equal to omega A. Therefore.
What? Huh? V is equal to omega A. Huh?
Omega is equal to V to...
Oh, that is... I might write down my thing. Woo! Where's that? Amplitude. Okay, so that's useful information.
Divided by A, keeping oil at a steady rate.
Wait.
So the answer is D. 5.
Wait, what?
So it's 24 divided by, careful, it's in centimeters.
Oh, I didn't change it to meters as well.
So the answer is...
Oh. The angular frequency is the angular velocity. No, I don't have Swinho. I have Paul and someone in Q2. So let me just... So it is... So you do V equals thingy A, and then we know the velocity is 24 equals omega. I need to say that. I've been saying theta or something, and it's 5.6 in meters. So you take 2 off 0.056. Then you do 24 over 0.056 equals that, which is 429 or D. Okay, right, that makes sense. Now it's probably going to take about 15 minutes to find the next. Ah, never mind, we found one. This is question 7. Pendulum bob oscillating in a vacuum. The maximum height of the bob is 1.3 meters and the height is 1.1 meters. Calculate the maximum speed of the pendulum bob. How the fuck did I do this? So it's just like, well, I mean, it's gonna be on this. Maximum what? Speed. No. I don't know that. I don't know that. See, it's like where? Oh. Oh. This is part of circular motion. Wait, no, that's oscillating. Fuck. It says it in the thing. If we know gravity. How the fuck do you do this? Okay. What does the guy do?
Height. What do I always say? If you see a height, then you know it's going to be all about energy.
Energy.
It doesn't matter what this is. If we have a height, we can find out the speed. So all we do is say that kinetic energy at half mv squared is equal to gp, that's mgh.
Oh my god.
M's cancel, therefore speed is equal to square root of 2gh.
Is that something... like funny square root signs? No. No. So that's just, you've got to use your brain. So if I'll do the actual calculation. So kinetic energy equals mgh, which is mass times gravity is force, force times distance is energy. Facts. Masses will cancel, as he said. So v squared equals half gh root, then v equals root half gh. No, v equals root half 9.81 0.2, and then you go thing 0.5 bracket 9.81 close bracket open bracket. Don't want to leave that. I need a calculator, Cam. 0.2. Oh well, what the fuck? What the fuck?
So that's square root of 2 times 9.8 times, what's the difference?
It's 9.81.
0.2 meters, methinks. And that gives us like 1.98, so therefore the...
Huh? Oh, fuck. Shouldn't have halved it. Should have times it by 2. And that'll give me 1.98.
That's it.
Which rounds up to 2. Okay, that's fair. That's fair. I'll take another L. That's not. That's that. That's that. Solar system. Stress and strain, don't care. No. No. Speed of a galaxy. That's not. No. 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 Oh. That's not. Ooh. Natural frequency. Ah! This is 18. Oh. Liked. Oh, that okay. Oh yeah. Why is that in my liked? I didn't like that. That's cap. Hard cap. Um. 18. So vacuum. So there's no air resistance. intention at all times. Defining Among Us for the spring. Let's have a look at the thing, because I don't know what that is, so I'm going to have to guess. What does it give me? I want a frequency. So it's going to be something with a frequency. I think it's going to be this. Yeah. Has to be that. Gives me a distance. Never mind. What is the defining equation? I haven't known any of this. This is awful. We're literally all gonna do bad. There's gonna be etymologies. We're like, I don't care. Fuck. Oh, X. X cos. No. Gives me a time, mass. Wait. Gives me a time and acceleration and a displacement. Doesn't have. Oh, and then I can use that to get F. So I can. Yeah, because I don't. The time doesn't matter. Right, I'm gonna try that, and that was the A equals minus thingy squared X, and then we'll plug in the values of 3.6 equals no. Fuck off. What's A? No, I'm just finding the acceleration. I know the. No, yeah. 3.6 equals minus thing squared 4.6 times that to the minus 2. 4.6 over 4.6 times 10 to the minus 2. By the way, 4.6 times 10 to the minus 2. 1800 over 23. I'm gonna root that. That gives me an extremely complicated answer. Oh yeah, it says about 1.4, so this should be could be okay. 8.85 equals minus thing, so change that. Okay, so then we're gonna interpret that in. What's the amount of 3 marks? Yeah, that's about two things. No, this is stupid. What is it? Simple harmonic motion. I don't get where this comes from. Like, this will be one equation. Surely. Or I'm just being an idiot, which is equally as likely. Alright, fuck it, let's just keep doing this. Hopefully I get it right. And then omega equals to thing F. Minus 8.85 divided by 2 pi. I'm an absolute god. Except the minus didn't really. If we just accidentally miss out the minus, 1.41 equals 1.4 really HZ, and that's the right answer. Let's go! Yeah! 18. What did this guy do?
It's about 1.4 hertz. Write down X, and we might need a time later.
A equals thingy X, but why? A equals. Why is it not put minus in? Why is it there?
Drawn, but not yet. So A is equal to 2 pi f all squared times X. Rearranging this, A over X is equal to 2 pi f square root of that. So f is equal to the square root of A over X divided by.
So it's the same thing, he just didn't use the minus. write down my thing. What did I call this? A-level physics, please let it end. Nice. Squared x. 4. What type? Equals 1.4 question. So I still got it right though, so that's fine. Probably wouldn't have got all the marks because I didn't do something unbelievably stupid though. To how the amplitude A, I figured out that V equals thingy A. Or does anything else have... Does anything else say radius? Something say radius that doesn't have V in. Did I use that? No, I didn't. A equals... Wait, what am I looking for? Amplitude is the radius. A equals... Thingy squared. Oh! He used X. No, I need to give that an underline. Oh, I'm getting quite tired. Because I know. No, because I actually used the same equation. Because I'm going to use the same values I literally just got. Surely, if it's saying I need to show that equals thing, then surely I have to use it, or it's just an absolute scam. Or did I use that? Did it give you the frequency? No, because that gave you the displacement. So he didn't use that. He just. Huh? V. Whoa. Oh, I know what I need. Yeah. This is it. We're gonna go for A equals among drip. Oh, I don't know what equation to use.
Okay, so I think we have a time. What equal speed that displacement was? Ah, look actually.
Huh?
Time if it was.
Oh, it's the shit, cos. So if you look, it's so I never want.
T. And if it's
Let me pause Nokia ringtone.
Then we're going to use cos. So therefore, amplitude. Add amplitude.
So
we know that the initial equation for SHM is the displacement at any time is equal to the amplitude times sine or cos. Ooh, are we going to use sine or cos? Let's have a look actually.
Wait, let me go all the way to the back.
2 sig figs. And that gives 1.4 hertz. Calculate A, the amplitude. So let's have a think. We are looking for an amplitude. What do we have? We have an x, we have acceleration, and we have a time. What equation has amplitude in? Well, the speed equation does.
Alright, so basically what you do, you look. Oh, I need a question with amplitude in. And that is that. So it's going to be x equals a something speed thing t.
We're not dealing with that maximum speed, that is. But we know that the initial equation for SHM is the displacement at any time is equal to the amplitude times sine or cos. Ooh, are we going to use sine or cos? Let's have a look actually.
Do we need sine or cos? Which one do we need?
So look at this. At time 0, it's not at equilibrium. So we use sine if the ball is at equilibrium to begin with, but if it's at amplitude.
So, what this says is that when the thing, mass, is at an amplitude, it's not at rest or equilibrium, you should just say that, then it is, wait, what did I say? If it's at equilibrium, then it's sine. And if it's not, it's cos. That makes sense. So it's cos because it says at time equals 0.
Then we're going to use cos. So it's not at equilibrium. So we use sine if the ball is at equilibrium to begin with, but if it's
at the beginning, if it's at equilibrium, then you use sine. But if in the beginning it's not at equilibrium, then it's cos. And it says in the question, it's not in the equilibrium somewhere. So it's cos. I'll put that in the equation.
At amplitude, then we can use.
So, and then we have the values we need. X is 4.6 times 10 to the minus 2. A, I'm looking for. What's the... I need to... Oh! Not doing anything right now. Not doing anything right now. I promise I'm not... people better have heard that. Because I'm clipping it. Hopefully I can get money. Oh, matter. No. Go away. I need my channel. I love doing this. I love doing this. So now I can listen to myself. Or we can listen to ourselves. So now I can listen to myself. Oh, we can listen to ourselves. Anything right now. Oh, I can just close this. I promise I'm not... people better have heard that. And then we have the values we need. Right. X is 4.6 times 10 to the minus 2. Now, we're going to look. A, I'm looking for. What's the... I need to... Oh. And then we have values we need. X is... Yeah. And then we have the values we need. X is 4.6 times 10 to the minus 2. A, I'm looking for. Physics revision. What's the... I need to... Yeah. We have the values we need. I'm going to close that. Return to Arab ringtone. On the equation solver, a mung drip, because gee, I imagine it's like that. It fucking better be. What's the speed of sound? 8.85. Is that kid crying in the background? What was the time? 6.5. Da-da-da. 8.85 times 6.5. Cause of that. Fuck. 0.5369. Ha! That's definitely a kid crying. I probably shouldn't have that, actually. That's bad. I'll go to this. The classic. Oh, I haven't listened to this, actually. Do, 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 do. 0.086.
Must be on time.
2 pi.
1.4 times the time. 6.5. Alright, it gives the system now oscillating air 0.5.
Ah! So he doesn't use the previously calculated value because it's different. I'd take that, bring it over. So then, because what's the frequency? Was it 1.4? What was the other thing I needed? Time. Times. What? We got the same answer. Because I'm in degrees, probably. Yeah. Equals 0.809. And it's 4.6. 10 to the minus 2 divided by this value I have, and equals 4.6 times 10 to the minus 2 divided by and 0.057 meters. Oh, it's a writing question. Oh. What's this?
Paimon.
Oh my god. It's
Why
Genshin
are you
Impact.
looking at me like that? What in
I remember that. Nah. This is in terms of energy involved in operations of the S. So I remember this actually from the lesson. So it goes from energy in the spring, no, gravity to gravity and I'm gonna have to actually use my book. I think I'm allowed to. I think I wrote this as well. Dun 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 dun. Dun 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 dun. So it goes gravity and energy in spring and the kinetic energy to just the energy. No, because it'd be gravity as well. Gravity is always there. Is gravity always not kicking it about? Gravity always wants to do something. Do 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 do. Nah. Right, what does this guy think?
7 meters. System to describe the energy changes that will take place as the mass moves from the lowest
Oh my
point
god.
in its motion through the equilibrium position to the highest point in its motion. Okay, so we know that when it's at the bottom, we know that we have minimum GPE, but we have max elastic potential energy.
Oh, from the lowest point equilibrium. So when the string is maximum, middle. So yeah, just what it's doing and then thing. So it goes min GPE as mentioned with max elastic potential energy in the spring, as I said.
So therefore we can say that as it rises, GPE increases as E equals mgh. Fine. But elastic, or we can say strain energy in
Strain
spring
energy, okay.
decreases as E is equal to half kx squared. But we know that also ball does work against air resistance. And last but not least, we also know that when spring changes shape, its temperature is raised. Therefore, the elastic potential energy gets turned into GPE plus work.
So GPE increases, strain energy decreases, ball does energy against air resistance, so then the energy is transferred into the air because of the air resistance, because of particles and that in it. And then when the spring changes shape, its temperature is raised.
Work done against air resistance plus heat produced in the spring. Okay, we have changes shape, its temperature is raised. Therefore, the elastic potential energy gets turned into GPE plus work done against air resistance plus heat produced.
I ain't writing that. So, overall, as the spring rises, the GPE. I'm probably not even going to get any marks that increases. I'm calm. This is due to E equals mgh, because that is energy force times distance. You know what I'm saying? And that's 1 point. However, I put but, as he did, the strain energy decreases due to E equals half kx squared. The one that's similar to kinetic energy, but in terms of springs. Half mv squared is changed to kx. Yeah. And then we've got air resistance and heat left. And when the spring changes shape, energy is lost to heat. Energy is transferred, not lost, because you can't lose energy, because it just changes to a different thing. Transformed into heat, energy. I don't know. Finally, what was the other one? The ball does work on the air so does work outro against air resistance, so energy is transferred into the air. And that is 4 marks. Oh yeah. Is there any more to that question? No. Oh my god, another one. Right after it. Right, I think I might do this and then cry. I've been doing this for half an hour and I literally already want to end my life. What is this? 19. What? Oh, it's just not done. Oh, for fuck's sake. So, C. Used a maths where that's just it and the question is over. I'm going to put that in mechanical thingy. So it's, I don't know, it's a driven oscillator or something, I don't know. Oscillating air, so air resistance is a thing. 0 to 2.5, 1, 2, 2.5. I can't sketch on the graph, but I'll just have to show that I know what to do. Sketch a graph to show the variation with vibrator frequency of the amplitude of the mass. Well, it'd be like, would I not do that? But it doesn't have a minus. Because it would go, huh? I don't know if the, oh, here we go again. I'm gonna piss myself. I don't know how it wants me to answer this.
Okay, so that of the amplitude of the mass, right? We know that we have the max amplitude when the driving frequency is the same as the resonant or natural frequency.
Resonant. I want to go to sleep. I'm so done already with life.
It can oscillate with variable frequency. Okay, so the vibrator frequency is varied from that. So that we know that the resonant or natural frequency is 1.4 hertz. So being asked to show the variation with vibrator frequency of the amplitude of the mass, right? We know that we have the max amplitude when the driving frequency is the same as the resonant or natural frequency. So there's 1.5, so 1.4 is 1, 2, 3, 4. Let's say that it's there. So we know we're going to have a maximum amplitude. So of course we're going to have a maximum amplitude at
And we figured out
this
the
frequency,
amplitude
so let's just put
beforehand.
it across there. It's not going to go down to 0, of course. It is going to oscillate a little bit, but we can do something like this. There we go. Light disc is now attached to...
Oh, is that it? So you just know amplitude F 2.5 1.5. I know 1 0 0. That is 1.4 because I did from the previous thing. It said that that's the resonant frequency, and when it's the resonant frequency, that's when it's like, that's when it's really good. Because if it's not the resonant frequency, it'll oscillate. So resonant frequency, it might do that, we'll say, and then not at the resonant frequency, it'll do like that. So, and then I'm gonna say that is, I don't know, like he did just before, and we know it's not going to be at 0 because I don't know. Did he say why?
It's not going to go down to 0, of course. It is going to oscillate a little bit, but we can do something.
Yeah, it always oscillate a little bit. So I'll just, yeah, that's good enough.
Something like now a new variation of the amplitude.
A light disc is now attached. Why not do this? You probably can't see a bit of the question, but well, that's too
Label
bad.
this graph D. Sketch a second graph.
So it's a second light disc is now attached to the mass. So that would mean the thing would be less. And I did this graph beforehand. Just do that. No. Cross at the same point. D.
To show the new variation of the amplitude. Label this graph D. So damping with
Oh yeah, it goes left. Wait, what?
amplitudes as well.
Oh, it's a light disc. So it still goes up, but it's also slightly left because the resonant frequency goes down slightly.
So something like this. So we end up with the graph being shifted slightly to the left, and also because of the damping, we have a lower amplitude.
So
as
it
well.
goes left
something
and down.
Like this for engineers when designing.
Explain why the phenomenon suspended footbridges. Oh, he knows. This is going to be on it. I reckon this question's going to be on it. I can't say why though. He would just watch the fucking. Bridge problems. He knows. He knows.
Suspended footbridges.
Yeah, it has
So
to be.
we saw this happen with the Millennium Bridge in London.
Yeah, no, Millennium
Footsteps
Bridge.
act as driving.
So, the footsteps on the bridge. No, dot bridge. Bridge act as a driving force. And then what are the right words I'm supposed
Force.
to
If
put?
frequency is similar to the natural frequency,
And if the frequency is similar, yeah, it doesn't have to be exactly on the dot the same.
resonance can occur. If frequency is similar to the natural frequency,
To the natural. Does it? No, it doesn't say that, so I should write that.
act as driving force.
Natural frequency, then resonance can occur.
If frequency is a break.
Resonance. No, not resonance. Resonance. Okay. Then as the amplitude increases, it can cause the bridge bridge to become unstable and break. Am I done? Oh, fuck me. And break. That's it. I'm. Ah. No, I'll see if that's all of the specific stopping distance, force time graph for bike, kinetic theory, screw coupler modes, star luminosity, particle. Yeah. Solid.
19 cars.
No. Ah, give me the fuck out of it. That was solid. Yeah, did some nice